Welcome to AI Frontiers. Today's episode examines recent advancements in computational linguistics, synthesizing key research from the arXiv preprint server dated May 8, 2025. The selected papers explore cutting-edge AI applications in language processing, with particular focus on three critical areas: model alignment with human preferences, bias mitigation in AI systems, and enhancements to multilingual capabilities. These 27 studies collectively push the boundaries of how machines understand and generate human language. Computational linguistics serves as the interdisciplinary bridge between language, artificial intelligence, and societal applications. This field develops core algorithms that enable machines to process human language, powering technologies from virtual assistants to translation systems and content moderation tools. Current research challenges include improving alignment between model outputs and human expectations, reducing biases in generated content, and enhancing performance across diverse languages. There is growing emphasis on creating more interpretable and computationally efficient systems to meet these demands. A significant research theme emerging from these studies involves preference alignment techniques for large language models. Chen and colleagues introduce an innovative method called ComPO, which utilizes comparison oracles rather than traditional preference pairs. This approach effectively addresses common issues of verbosity and misalignment in model outputs. The method provides theoretical convergence guarantees, ensuring more reliable training outcomes compared to conventional approaches that rely on direct human feedback, which can often be noisy or inconsistent. Multimodal integration represents another major research direction, combining vision and language systems to enhance reasoning capabilities. Research by Shiqi Chen and collaborators demonstrates how different layers in these models specialize in distinct functions, with early layers handling perceptual tasks like object recognition, while later layers manage higher-level reasoning. Their work on model merging shows how reasoning capabilities can be transferred between systems without disrupting perceptual functions, suggesting pathways for more efficient AI architecture design. Addressing bias and misinformation forms the third critical research theme. Studies reveal how AI-generated news headlines can exhibit framing biases, while other researchers introduce specialized datasets like UK election narratives to detect misleading political claims. These investigations highlight the growing societal impact of language models and underscore the need for improved safeguards. The research also identifies persistent challenges in achieving consistent performance across different languages, particularly for low-resource linguistic contexts. Several key findings emerge across these studies. The ComPO method not only improves alignment, but provides mathematical proofs of convergence, representing a significant reliability advancement. Vision language models demonstrate modular capabilities, with perception and reasoning functions localized to specific layers. Notably, models like MIXTRAL-8X22B-INSTRUCT show promising performance in languages such as Bangla without extensive fine-tuning. Other breakthroughs include InViseal's order invariant, in-context learning, and novel approaches to modeling human preferences through latent codes. Methodological innovations underpin these advances. Researchers employ sparse autoencoders to decompose complex model activations into interpretable features, though this requires substantial computational resources. Conformal prediction methods offer statistical guarantees for detecting machine-generated text, while model merging techniques enable capability transfer without retraining. Gradient-free data selection approaches reduce computational costs, and chain-of-thought prompting demonstrates variable effectiveness across different linguistic structures. The ComPO paper by Chen and colleagues stands out as particularly influential. This work addresses the persistent challenge of noisy human feedback in AI alignment by introducing comparison oracles. The method's theoretical convergence guarantees represent a major step forward, with practical tests showing superior performance on models like MISTRAL-7B and LLAMA-3-8B. These advancements are crucial for reducing common issues like excessive verbosity and misaligned responses in language model outputs. Another seminal contribution comes from Shiqi Chen's team, investigating vision language model architectures. Their research reveals how perception and reasoning are distributed across different model layers, with early layers handling visual perception and later layers managing reasoning tasks. The demonstration that reasoning capabilities can be transferred through model merging without disrupting perception opens new possibilities for efficient AI system design, with implications for robotics and multimodal assistant development. The QualBench study by Hong and collaborators addresses a critical gap in AI evaluation by creating Chinese language benchmarks based on professional qualification exams. Surprisingly, the Qwen 2.5 model outperforms GPT-4o on these specialized Chinese tasks, highlighting the importance of localized training data. The paper advocates for federated learning approaches to overcome data scarcity in niche domains, providing a blueprint for more inclusive AI development that moves beyond English-centric evaluation paradigms. Future research directions face several challenges and opportunities. Scalability remains problematic for methods like sparse autoencoders when applied to billion-parameter models. Improved bias mitigation techniques are needed, particularly for understanding framing biases in generated content. Expanding datasets for low-resource languages and developing modular architectures present promising avenues. Human-in-the-loop alignment approaches that combine latent preference coding with real-time feedback could lead to more responsive AI systems. Sparse autoencoders, as investigated by Deng and colleagues, offer important technical insights. These methods decompose complex model activations into interpretable features, providing windows into AI decision-making processes. While computationally intensive, such approaches are crucial for developing more transparent AI systems. The ability to break down and analyze model activations represents a significant step toward understanding and improving neural network operations. Conformal prediction methods, explored by Zhu's team, provide statistical frameworks for detecting machine-generated text. These techniques offer reliability guarantees that are valuable for content moderation systems, though they may reduce sensitivity in certain applications. The balance between accuracy and reliability in these detection systems remains an active area of research, with important implications for maintaining information integrity in digital spaces. This presentation was synthesized using advanced AI systems, including GPT DeepSeek for content generation and Deepgram for text-to-speech optimization. Visual concepts were developed with OpenAI systems, and all material underwent human expert review. While every effort was made to ensure accuracy, listeners should note that potential oversights may exist in this complex and rapidly evolving field of study. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.